So let's turn our attention to kind of the last topic in this class, and that's discrete probability. Now, a probability is just a likelihood that some event occurs. Now, I'm going to talk about events later, okay? But let's talk about likelihood now. So a likelihood is like a percentage, right? So you can give a probability as a percentage between 0% and 100%. 0% means the event is definitely not going to happen. 100% means the event is definitely going to happen. And things in between just, give you a range. So it might, for example, rain 30% today. And what that means is that days like today, 30% of those days, it will rain, okay? It is traditional to give probabilities not between 0 and 100%, but between 0 and 1, which is pretty much the same thing because percent means divided by 100. So you're talking between 0 and 100 divided by 100 or 1. But you'll see probability is quoted as 0.2, meaning 20%, okay? Now, in order to get to event, I need to start by talking about a state, okay? And state is a technical term, okay? So here's the definition. A state is just some configuration that a system might be in, okay? So let's take a light switch, okay? The light switch could be on, the light switch could be off. Those are the only two possible states for a light switch, right? Those are the two configurations that a switch could be on. Or how about a coin? Well, a coin may have landed heads or it may have landed tails, right? Those are the only possibilities for a coin, that's it, okay? How about a die, right? Roll a die, I can get back either 1 or 2 or 3 or 4 or 5, 6. Those are the only possibilities for a die. So, those are all states. Now, when I talk about all the possibilities, right, then what I'm really talking about is kind of a set that contains all the possible states for whatever experiment I'm doing. So if I'm, flipping coins, then all the possibilities are heads and tails, and I can think of a set, heads, tails, that's the entire state space for coin flipping, okay? For die rolling, it would be the set that has 1, 2, 3, 4, 5, 6, okay? Now, state space is kind of a word that computer scientists will use, okay? Statisticians, when they talk about this, they usually use the word sample space. And the reason they call it sample space is because, they think in terms of populations, and you sample some observations from that population. So it's the sample space, okay? It doesn't matter what we call it. It's a state space, a sample space. It just means the same thing. It means all the possible outcomes, all the possible configurations that a particular object could be in, okay? Very important, states are exclusive, okay? And this actually makes perfect sense, like a coin. It can't be heads and tails at the same time. Or a die can't be showing 2 and 5 at the same time. So that's what a state is, right? It's just a possible configuration. They're all exclusive, right? Now we can talk about events, okay? So an event is actually just a set of states, right? So for instance, I can look at rolling a die, and I might be interested in any of the states 2, 4, and 6, right? Or I might be interested in any of the states 4, 5, and 6, okay? Now notice that events are not exclusive, right? The states are exclusive. It can't be 2 and 6 at the same time, but it could be 2, 4, or 6, or 4, 5, and 6 at the same time, right? Because some of those states are actually in both of these events, okay? So those are the basic terms that we need to do probability. All right, and so now remember that a probability is just the likelihood that some event happens, right? So let's make that super formal, okay? What we really have is the probability is a function, okay? And it's a function that goes from the power set of the state space or the sample space, right, into the numbers between 0 and 1. These are the real numbers between 0 and 1, okay? So there have to be some conditions in order for this to work. And here's the first condition. The probability of the entire set, right? And remember, the entire set is an element of this power set, right? Has to be equal to 1. That's just because something has to occur, right? If I actually flip a coin, it will be either heads or tails. It can't come back on edge, right? That's not one of the acceptable states. Okay. Now, what about the probability of the empty set? Well, that has to be 0 because if I say, what is the chance that nothing happens? Well, that's 0. Something's going to happen, right? So this is kind of the flip side of saying that probability of the entire set is 1. I mean, that almost necessarily means that the probability of the empty set has to be 0, okay? Now, another thing that has to be true is that the probability of anything has to be greater than or equal to 0, Okay, so that means that I can say, well, the probability that the die comes up either 2, 4, or 6 is -5. Right? That doesn't make any sense, right? It's either never going to happen. That's the least likely possibility, right? In which case the probability is 0. It can't be anything less than it's not going to happen. Okay, and finally, we have the probability of a union of events. So if I have two different events, and let's assume for now that the events are disjoint, okay, so that they have no states in common. Well, then in fact, the probability of the union is just the sum of the probabilities, right? And this should remind you a lot of the sum rule for counting, where the sum of two disjoint sets was just, I'm sorry, the number of elements in two disjoint sets was just the sum of the elements in each set. Okay. Let's just get some examples of it so we get this figured out. Suppose that I have a dice fair, right? So that each face is equally likely. Then the probability of 1 is the same as the probability of getting 2. It's the same as the probability of getting a 3 and so on. And if I take all of those probabilities together and I add them up, I need to get 1, right? So what ends up happening is that the probability of each one of those events has to be 1/6. They all have to be equal. They all have to add up to 1. So there's no choice, okay? Here are some other things that we have. Of course, 1, 2, 3, 4, 5, 6, probability is 1. The empty set is 0. Those are just taken for the definition of probability. How about 2, 4, 6? Well, that has to be a half because 2 is a 6, 4 is a 6, 6 is a 6. And since those are disjoint, I can just add them and I get 3, 6 or a half. Same goes for 4, 5, 6. Same goes for 1, 2. I get a third, okay?